video will show you how Spanning Tree Protocol works. There will be 5 switches in this example network. The very first step in Spanning Tree process is to determine which is the root bridge. Initially all the bridge will assume itself as a root bridge until it receives a BPDU with a lower bridge ID. In order to determine which switch is the root bridge, we find the switch with the smallest MAC address, or we may use bridge priority. In this example, we determine the root bridge by using the smallest MAC address, which switch 4 has the smallest one. Thus switch 4 is the root bridge. The second step is to determine the root ports for all bridges except for the root bridge. Generally, all the bridge ports that are directly connected to the root bridge will be the root port. In this example, we assume that all network has the same bandwidth of 100 megabits per second. Thus the following port are the root ports. Since switch 1 is not directly connected to the root bridge, we determine the root port for switch 1 by choosing the network which is connected to a switch with the lowest cost. In this scenario, the MAC address of switch 3 is the lowest compared to switch 2 and switch 5, thus the following port is the root port for switch 1. The third step is to pair all the root port with designated port. The network between switch 5 and the root bridge. The network between switch 3 and the root bridge. The network between switch 2 and the root bridge. And the network between switch 1 and switch 3. Next, for all the remaining lane segments in the non-root bridge, we must determine the designated port and the blocked port. To do so, we give priority to those having the lowest cost to the root bridge, then the lowest bridge ID, and then the lowest port ID. Switch 5 is already connected to the root bridge, thus we do not require the network connecting switch 3 and switch 5. Since the MAC address of switch 3 is smaller, we block the port at switch 5. The same scenario goes to switch 2. Since the MAC address of switch 3 is smaller, we block the port at switch 2 for the following network. At switch 1, the MAC address of switch 2 and switch 5 is smaller than switch 1. Thus we block the port at switch 1 for the following networks. Now, we pair the blocked port with designated port. The blocked port at switch 5. The blocked port at switch 2. And the blocked ports at switch 1. There we go, our Spanning Tree Protocol is now completed.